From the Library of Congress in Washington, D.C.
Good afternoon and welcome. I'm Jane McAuliffe, the director of the John W. Kluge Center here at the Library of Congress, and we are gathered this afternoon for the final portion of a two-day symposium, a dialogue that the Kluge Center has hosted in collaboration with the NASA Astrobiology program. The title of this two-day dialogue has been Astrobiology and the Religious Imagination, Reexamining Notions of Creation, Humanity, Selfhood, and Cosmos. The Library of Congress also always takes on such tiny topics. This is as big as it gets. So this is also the moment in our program when I ask you to silence your cell phones and any other electronic devices you have with you. Today's program is being filmed for the Library of Congress and the Kluge Center websites, as well as for future placement on the library's YouTube and iTunes channels. I'm going to say just a very few words about the Kluge Center, about the Bloomberg Astrobiology program, and about our two terrific conveners. The Kluge Center was created about 15 years ago through a very generous gift from philanthropist and entrepreneur John W. Kluge. The Kluge Center has three major functions. First of all, it is a residential center for scholars. So each year we create a scholarly community of about 100 researchers in residence. These are senior scholars, postdoctoral fellows, and doctoral candidates from around the US and across the world. And they come here for periods ranging from several months to a full year. They come here to use the world's largest library and some of its very special collections. So that's our first function. Our second is that every few years we prepare the Kluge Prize for the Librarian of Congress. The Kluge Prize is a $1 million award. This year it's going to be $1.5 million as we celebrate our 15th anniversary. An award that recognizes lifetime achievement in the study of humanity. Previous prize winners have included scholars like Peter Brown, the historian Peter Brown, philosopher Paul Ricoeur, scholar of early India Ramala Thapar, and most recently the political economist and former president of Brazil, Henrique Cardoso. And finally, we offer a continuous series of seminars, lectures, symposia, such as the one that we're hosting this afternoon. A very special form of this kind of work that the Kluge Center does will occur in mid-June when we bring to Capitol Hill about between 75 and 80 of our former scholars and fellows for what we are terming the first Scholar Fest on Capitol Hill. Now to the Bloomberg Astrobiology program. This is really the result of a unique collaboration between the Library of Congress and the National Aeronautics and Space Administration own program in astrobiology. It takes its name, the Bloomberg Astrobiology program, from Nobel Prize winner Baruch, known as Barry Bloomberg, who was founder of the NASA Astrobiology Institute, and he was also a founding member of the Library of Congress's Scholars Council. Dr. Bloomberg envisioned the creation of a program in the Kluge Center that would connect scientific discoveries in the field of astrobiology with the best thinking in the humanities and social sciences. The astrobiology program, then, is an example of the varied and significant research subjects that the vast collections of the Library of Congress enables. The Bloomberg Dialogues are specifically designed to gather groups of distinguished scholars in the humanities. This first dialogue has brought together scholars in the field of religious studies. They have spent a day and a half in conversation. I've been able to go in and out of those conversations, and they have been truly fascinating. So we're looking forward to hearing their reflections this afternoon. The next dialogue will gather historians and philosophers of science and will take place here on May 28th. We're very grateful to Derek Malone France and John Baross for directing the dialogues, and let me just say a word or two in introduction of them. Dr. Derek Malone France, right here, is Associate Professor in the Departments of Philosophy and Religion at the George Washington University, where he is also the Executive Director of the University Writing Program. This past fall, he taught a course at GW entitled Human Existence and the Search for Life Beyond Earth. I bet many of you would like to have been in that course. It explored contemporary philosophical, religious, political, and social implications of our ongoing search for life in other parts of the universe. He's the author of 2 monographs. The first is entitled Deep Empiricism, Kant, Whitehead, and the Necessity of Philosophical Theism. The second, Faith, Fallibility, and the Virtue of Anxiety, an essay in religion and political liberalism. Dr. John Baross, next to Dr. Malone France, is professor in Oceanography and the Astrobiology program at the University of Washington. He specializes in ecology, physiology, and the taxonomy of microorganisms from hydrothermal vent environments, extreme ocean environments, in other words. More broadly, he's interested in the origins of life and the possibility of life on other planetary bodies. In recognition of his work, Dr. Baross is an elected fellow of the American Academy of Microbiology. He's a member of the American Society, the American Chemical Society, the American Geophysical Union, and the International Society for the Study of the Origin and Evolution of Life. I'd now like to turn this over to our 2 conveners and to thank you again for being with us this afternoon.
Thank you very much. And thank you to Jane McAuliffe and the entire staff of the Kluge Center. It's been a real thrill to be involved with the Bloomberg Project over the last 3 years, first as a member of the selection committee for the chair, and now with John as co-seminar director for these dialogues. And the staff at the Kluge Center, I cannot say enough. I don't want to go through names, it'd take too long, but they're just a wonderful group of people to work with. We are joined today, I'm not going to do introductions other than just their names and affiliations, but you, as Jason said at the beginning, you have that information on the handout. Besides myself and John, we have Stephen Benner, who is a distinguished fellow at the Westheimer Institute for Science and Technology, Jonathan Lunine, the David C. Duncan Professor in the Physical Sciences at Cornell University, Donald Lopez, Arthur E. Link Distinguished University Professor of Buddhist Studies at the University of Michigan, Pamela Klassen, Professor of Religion at the University of Toronto. I missed Ebrahim Moosa, Professor of Islamic Studies at Notre Dame. Sorry, Ebrahim. Susannah Heschel, Eli Black, Professor of Jewish Studies at Dartmouth College, and John Hart, Professor of Christian Ethics at Boston University. NASA's roadmap for astrobiology defines the field as encompassing 3 main axes: the origins and evolution of life on Earth and elsewhere, perhaps, the search for life elsewhere, and the future of life, both on and beyond Earth. So it's a tremendously expansive, obviously inherently interdisciplinary field. And we had the pleasure of bringing in another extremely expansive and interdisciplinary field in religious studies for this dialogue. And religious studies, I should clarify for those of you who might not know, is very different from religious education. The field of religious studies is the scholarship of education as an object of academic inquiry. So although our panelists in some cases study particular religious traditions, they don't necessarily bear the burden of speaking on behalf of those traditions as practitioners. The format is going to be fairly straightforward and we hope interactive at the end. John will say just a word to get us started, and then each of our panelists will offer brief remarks encapsulating some of what they have taken away from our conversations over the last 2 days, hitting upon a number of important themes that we identified together as priorities for further exploration. We have two of our panelists who have been gracious enough to stay right to the very moment they have to leave for the airport, and so they're going to get up before the Q&A. Pardon them for that. We're just grateful that they stayed for this part of it. The panelists will respond to each other a little bit, but also there will be an open Q&A with the audience, which I will moderate. So I'm going to sit down in a second and let them take over, and when they finish, I'll stand back up, and from here, I will gesture to the audience for questions. There are going to be 2 mics in each side of the room. So let's go ahead and get started.
So thanks, Derek. And thanks again to the Kluge Center and to all the panelists who were invited to come. And I'm only supposed to say 3 or 4 words, so I'll leave them as much time as possible. But I'd like to point out that Derek and I had been talking about these kinds of dialogues on how to bridge some of the issues that might come from discoveries from astrobiology into religion, and eventually a second dialogue will probably be much more philosophical. So the question is that astrobiology is really concerned with the possibility of life in the universe, its origin, its evolution, its complexity, and its potential ubiquity. And we're also very interested in, philosophically in a way, why are we wanting to explore? What are we looking for? Why do we want to look for life elsewhere? So some of the questions frequently addressed in astrobiology are, what is life? What is the course of life? Are we alone? And who are we? And what discoveries, I think, could help address us in moving, address these kind of questions, and what effect would they actually have? Currently, there's no universally accepted definition of life. We have some characteristics of life, and that was a topic of discussion. Those characteristics include that it's carbon-based, it is self-sustaining, and it undergoes Darwinian evolution. The latter actually stimulated some very interesting discussions on this, as you can imagine. If evolution proceeds, let's say, in a contingent manner, would we expect, I think, the evolution of life forms, let's say, elsewhere that had 4 billion years to actually evolve? Would they resemble us? Would they be something different? And what if there's a life planet that's perhaps thousands of years to millions of years older and still has life? What would that life become? What would it look like? And how would it influence the way we think from a religious perspective? Those are some of the questions that I think we discussed. We'll hear from Jonathan in a couple of minutes. Our search for life is both in our solar system, and he's going to talk about some fantastic places that might actually harbor life, the finding of an n equals 2, a second form of life, and whether or not it's same as Earth or different, there's a separate origin of life, would be hugely affect the way we think scientifically, and we're hoping that it's going to have even broader implications than that. As many of you know, that we are searching for Earth-like planets outside of our solar system, and while we're just focused on a very small component of it, in the Milky Way, there's approximately 100 billion stars, of which our own sun is just one. And so we're looking at just one small segment, and I think already in the last few years that we have identified more than 1,000 planets that are of interest. Not exactly Earth, but certainly of interest. And it's given most of us involved in this program tremendous confidence that it's only a short time before we find an Earth-like planet. That's the optimism of astrobiology. So I'll leave it to Steve.
Well, thank you, John. First, like John to my right and Jonathan to my left, I am an astrobiologist. I should make as a comment, programmatically, there are astrobiology institutes and nodes thereof all around the United States and indeed around the world. You can all go study astrobiology. You can get degrees in astrobiology. In fact, old, middle-aged, young, at any age, if you're just retired and want something to do, you can go to University of Washington. And you'll be in for a wild ride because it includes all sorts of disciplines. I, of course, am trained as a chemist, and of course this reflects the fact that biology over the last century has been, to a large extent, reduced to molecular descriptions. So we have sequences of the human genome, for example, which is nothing more and nothing less than a description of where carbon atoms and hydrogen atoms and phosphorus and nitrogen atoms are present in the molecules that just happen to be involved in inheritance. But of course, we have amino acids in our proteins, 20 of them, perhaps a few more every now and then. This is a molecular description, a chemical description of biology. And of course, one of the big puzzles in modern biology is how you get the properties that we value in life out of the molecules that we are able to analyze and detect in modern living systems. One of the surprises, to some extent disappointments, that we have discovered as we've gone around the planet under almost every rock where there's water and some energy, there is something living. But no matter where we look, the chemicals seem more or less the same. You have pretty much the same building blocks for your DNA, the same amino acids for your proteins. And this is currently interpreted as evidence that all of the life that we know of on Earth is descendant from a single common ancestor, which had basically the core biochemistry that we know and love. That means that we do have these problems, as John mentioned, in defining what life is, because if we have really only one example of life, which is one example only in the sense that it's one origin, certainly one divergence, we actually are constrained. We are, as we like to say, earth-ocentric. We don't tend to have the imagination to go out and think differently than what we know. And that creates a problem, because if you go to Mars, if you go to Titan, go to some other locale in the solar system, unless that alien life form is prepared to shoot you with a ray gun, right, you have a hard time deciding whether it is life. And if you look at a lot of the examples, there was meteorite coming in from Antarctica, actually came from Mars by way of Antarctica. They were structured in that. They sort of look like cells to some people. There's a big fight over that. Of course, even going back to 1976, when Viking landed on the surface of Mars, there were 3 life detection tests. All of them turned out positive in some interpretation. And that, of course, sets in motion decades of scholarly arguments. I would use the word better than discussion, because some of them are quite nasty and personal, as to what life would look like if we were encountered at the molecular level. So, as John mentioned, we're looking for a second example of life, if only to describe or help us break free of our constraints imposed by limited human imagination as to how life might look if it had independent origin, if we were to encounter it in the cosmos someplace other than here on Earth. And of course, that's the general question right now. One of the questions is, how do you make a jar change your view, expand your horizons of the, in this particular case, the intimate relationship between molecular structure? Exploration is one way to do that, right? You can go out, and if you discover this in some way, you will get yourself a surprise, and that will change your way of looking at things. What we do a lot in the laboratory, of course, is to try to synthesize a second example of life, putting together molecules in our limited way that our imagination says might be different ways, different molecular ways of having children, having mutant children who can adapt to environments. So that's the perspective of the astrobiology from the chemist side. We're trying to understand, use exploration in part, but also use synthesis to understand just how life might be different if it's out there, what the chances are that it might have originated. Therefore, if we can find a second example in reality, we are able to say the chances of origination are higher, but also just to understand how chemistry can go and organize itself and to give systems that have the properties that we value in life.
Would you like me to talk?
I wouldn't.
Outstanding. Okay. So I'm Jonathan Lunine, and I am mostly a planetary scientist and astronomer. My passion is exploration of the solar system and also exploration of planets around other stars. for which right now we are living through really a remarkable revolution in both of those. My personal desire is for us to be able to discover life in my lifetime, and if it's after my lifetime, I'm not so interested. But, you know, we can sit back and we can listen with radio telescopes and hope that somebody will contact us, but that hasn't worked very well. So, in my view, we need to go out and look. And right now, going to other planetary systems is something that is not in the cards. We can look at other planetary systems with powerful telescopes, the James Webb Space Telescope, which will launch in 2018, is going to be able to make compositional measurements of the atmospheres of exoplanets, from which we will learn whether those planets are habitable, that is, whether they can host life, but it is very difficult to determine from that whether they're actually inhabited. So from my point of view, the solar system is the place to go to look for life elsewhere beyond the Earth. Now, if we go out in the solar system, we're looking not for intelligent, sentient creatures. We're looking for microbes. And you might say, well, that's kind of boring. You know, microbes are not so interesting. Microbes are really interesting because, in fact, if we find evidence on another planet or moon of microbial life that is different enough biochemically that we can make the case for a separate origin, a second genesis, or if that life is sufficiently isolated, is on a place that's far enough away, that the argument can be made that there was not transfer of material by asteroid impacts, then that will tell us that life is a common outcome of cosmic evolution occurring in two places in the same planetary system. So where do we go? Mars is an obvious place. It was habitable for at least the first billion years of its history. It has a surface now that is not habitable. But it is possible that life began there and then retreated into the crust, under the surface, where it is living now on a hydrogen-based ecosystem, essentially. And so finding a way to get into the crust and sampling that material is very important in Mars exploration. Jupiter's moon, Europa, is a lunar-sized body that has a salty ocean, a thin icy crust. We don't know if there are organic molecules there, but we can certainly go and determine if there are organics coming out of the fractures on that body and where one would go to find the smallest amount, the narrowest amount of icy crust below which you could access the ocean. And there actually is a mission now under study, funded by Congress, that NASA is studying to do just that, called Europa Clipper. The two places that I'm actually most excited about are in the Saturn system, Enceladus, a moon of Saturn, and Titan, Saturn's largest moon. Enceladus is a body that the Cassini spacecraft, a mission that I'm involved in, has discovered some remarkable things about. It has a plume of material coming out of the South Polar region through these fractures, kind of like a cracked bottle of soda where the stuff is pouring out. And Cassini has actually sampled this material multiple times with chemical experiments. It's found water, it's found salts that are dissolved in the water ice, which indicates that that water was originally liquid seawater that then froze as it came out, organic molecules, including methane and hydrocarbons, and as well, it's been able, from detection of these tiny particles that have silica in them, to determine that in fact there is a hydrothermal system in the liquid region in Enceladus's interior. And from other measurements, we know that this region is at least as large as a regional sea. It may be a global sea underneath the surface of Enceladus. But all that material is coming out into space, and so we don't have to land, we don't have to drill, just have to go back with the right instruments, do exactly what Cassini is doing, fly through the plume as it orbits around Saturn. And with this new mission, we would be able to detect the biochemistry and potentially determine if there is life and if that life has a different biochemistry from life on Earth. And then finally, very briefly, Titan, the giant moon of Saturn, has methane seas the size of the Caspian Sea on the Earth. If there's chemistry going on there that is evolving toward life or has crossed the threshold of life, the biochemistry would be totally different from that on the Earth. Can we recognize it? Interesting question. But if we do recognize it, then that tells us that life can form in any kind of liquid system, and that would be a really remarkable discovery. So those are the places I'd go in the solar system. I'm probably out of time, right? More or less. I do want to point out, though, very quickly that as far as intelligent life goes, we may not only be separated in space but also in time. One of the things that we talked about very briefly is that it took intelligent life 4.5 billion years to evolve on this Earth. Now that's only halfway through the main sequence life of the Sun, but as we understand the habitability of the Earth is 80 to 90% of the way through the habitability of the Earth. The habitable zone for our planet is drifting outward, and it will cross us, the inner edge will cross us in less than 1 billion years, and that's sobering. If in fact we turn out to be precocious, it may take longer for other planets to evolve sentient life, and we may well be very much alone, not necessarily unique, but alone in space and in time, and that to me carries with it many implications for the sacred and for the preciousness of who we are. And so with that, I will turn it over to my colleague Ebrahim.
Thank you very much. And I agree with everything that Stephen and Jonathan had said, and there's nothing for me to say. And Islam talks about surrender, so I surrender to science. And so I'm a good Muslim. But I wish it was that easy. There was a time when Muslim philosophers were talking to studying Greek philosophy, philosophers of India, and there was no canon and nobody telling them this is right and this is wrong, and they freely believed in ideas about that the world emanated, and they did not really think about the world being created at a particular moment in time in a very literal sense. And until the canon began to stabilize around about 11th, 12th century, you begin finding theologians saying that you cannot believe in X and you cannot believe in Y, and this is the standard way of belief. And so when the questions of science comes back onto the table, and astrobiology that awes us in a whole variety of ways, many Muslim thinkers go back to the early developments in Islamic philosophy, people like Al-Farabi, people like Avicenna, Abu Bakr al-Razi, who had a more creative approach to the world and worldliness, and gave different kinds of explanations that did not always line up with the scriptural teachings in the Quran or in the prophetic tradition. And so I would say that I'm going to talk about three things about the way in which we are challenged by the daily discoveries and the kind of things that Stephen and Jonathan have just been telling us and shared with us in the last couple of days, and hours for me this morning. I came in this morning about the ways in which the world in which we live has changed our own social imaginary, who we are and what we are, whether we are aware of it or not, and theologians are the last people to sign up to that change. And hence, I think the challenge within Muslim thought is that how to adapt and how to make these kind of alterations is a major challenge. However, millions of Muslims who do study science, who go to study engineering, who study the frontiers of modern medicine, do understand that that is a worldview that is actually real for them. And clearly, the theology might almost sound mythical. And hence, that is the battle today of how to make Muslim theologians understand that the question of science is part of our realistic worldview. Part of the battle is also that modern science, the way we understand it, astrobiology, happens across a cultural and civilizational chasm. And that cultural and civilizational chasm creates some obstacles. And so there's suspicion of whose knowledge and what is the project. And hence you find a great deal of defensiveness and apologia. Hence, the kind of apologia that you find is that when Neil Armstrong went to the moon or put his first steps out there, Muslims quickly found a verse in the Quran that says, you know, the heavens and earth is open and human beings will have traveled to there. But that, of course, you know, it will be bad for me to second guess what God had in mind there, but many millions of Muslims thought that they got it right and they were with God, that God actually thought about Neil Armstrong. Now, I have no doubt that God thought about Neil Armstrong and a lot of other things as an omniscient God, but I wonder whether that level of detail would have been in that conversation. Secondly, now, many people will fault me for saying that God does not know the details. And so I didn't say God doesn't know the details. I said I don't know whether God knows the details. Okay, get me right. I know this is recorded. And I don't want to be a celebrity. And so this is very important that we get that side of the story. The second point is analogy. Oftentimes, we think about other worlds and the way we try to expand the unknown on the basis of what we know. And so there is an Islamic tradition, and as I said, as one of my colleagues and I, we always talk, and we said all roads lead to Islam, because I was always telling her, you know, in Islam we have that. And so she started joking with me and telling me that all roads seem to lead to Islam. And that's the only thing I know. Where else can I take you? So there is a tradition of the Prophet Muhammad that says that God had created 7 heavens and earths. And in every earth, there is an Adam like your Adam, that is to the terrestrial, the geocentric folks. There is an Adam like your Adam, a Noah like your Noah, a Moses like your Moses, and a Muhammad like your Muhammad. And of course, this is highly controversial, but it does say something. If this was either authentic or fabricated or imagined, it shows a certain kind of imaginary, that the religious imaginary is open to certain kind of possibilities. And any imaginary can think about a life after death. That's quite fecund and quite creative. And so the possibility that the religious imaginary brings, if utilized creatively, can create many possibilities. Lastly, I would say the question of Al-Ghazali. Al-Ghazali was a theologian, very controversial. He died in 1111 in the 12th century. He called out Avicenna and some other philosophers for holding wrong doctrines. Many people blame him for attacking reason in Islam or attacking philosophy. I don't think so. He wanted to have a conversation with philosophy. But Ghazali gave a very interesting remedy to complex issues. In an epistle called The Rule of Interpretation, he says, there are 3 things that needs to stay in tension when we interpret things. He says, don't say you know it all. Don't say you know it all. In other words, have some humility about the facts of the world. Second, he says that don't abandon reason. Let reason also have a share in a conversation. And thirdly, he says that when there are uncertainties, when there are multiplicities, don't hold on to a singular viewpoint. You'll have to struggle. In other words, in the tension between don't refute reason, the idea that don't say you know it all, but grapple with the multiple possibilities, or your humility that there are many things that you do not know, grapple with that. And also at the same time, understand that where there's multiplicity, one singular view might not prevail. I think that gives me a real good handle to deal with some of the very complex issues and make myself vulnerable to new possibilities of understanding who we are, what we are in terms of self and other, our place in the world, what is the human person, that earlier pictures and earlier understandings of what the human person might have been, what our world was, what it is, and what it may become, it all becomes really possible if I utilize Ghazali in a more creative way and in terms of the 3-pointed tensions that I provided you here. So that is my point, and I'll leave it to the Buddhists to solve it.
Thank you. So I'm here to represent the Buddhist tradition. The Buddha lived 2,500 years ago in India. Religion spread across Asia over the next 1,000 years and has spread across the world in the past 200. So there's a lot to cover. I thought, however, that instead of going through all of that history, I would simply look at the 4 nouns in the subtitle of our topic today: creation, humanity, selfhood, and cosmos, and give you some idea of what Buddhists might say about these terms. Buddhism, for a variety of reasons, has been declared that religion which is most compatible with modern science. Perhaps this is because, unlike the Abrahamic religions of Judaism, Christianity, Islam, it has no creator God, and that its insights derive from a young Indian prince meditating all night on his 35th birthday. That is, a human, through his own efforts, discovered the nature of reality, and therefore is called Buddha, a Sanskrit word that means awakened, or that we translate as the enlightened one. So in a famous Buddhist discourse, an Indian ascetic approached the Buddha and asked him a series of 14 questions which the Buddha refused to answer. The first of those was, is the world eternal or not? So these came to be known as the 14 avyakrita in Sanskrit, the 14 undecided questions, the 4 indeterminate things. And a great Victorian translator rendered these as the 14 questions that tend not toward edification. And rather than answering these questions, the Buddha said that such questions would be like the case of a man who's walking through a forest and is shot by a poisoned arrow and just has a very short time to extract the arrow from his body before he dies. The Buddha asks, would at that point the man wonder to himself, I wonder whether the archer was tall or short. I wonder whether the wood from the shaft of this arrow came from a birch tree or an oak tree. I wonder whether the feather comes from a dove or from a hawk. All of those questions tend not toward edification in this case, and that one should instead try to extract the arrow and not deal with these speculative questions that have nothing to do with liberating us from suffering, which is the goal of the tradition. So on the question of creation, Buddhism, no problem. We don't talk about that. There's no answer to the question. Humanity, again, a powerful term and one about which Buddhism has, I think, a quite interesting perspective because, unlike the Abrahamic religions, Buddhists believe in rebirth and reincarnation. And what that means is that all of us have been reborn as every possible existing species in the universe many times. And therefore, our humanity is something that is very brief and contingent, and our next lifetime will be something else, and the lifetime before this one we were something else. And therefore, as we look across the universe, there's really a single species, the species of the sentient. That is, those beings endowed with consciousness, whatever we mean by that term. And so humanity is not something unique. All beings have been human, and we will all be everything else, even down to the molecular level, if there is sentience there, which is, of course, a question. Selfhood. If you've studied anything about Buddhism, you know that the primary insight of Buddhist philosophy is that there is no self. That is, among these various constituents that we call mind and body, there is nothing, no self, no soul, nothing that lasts longer than an instant, than a microsecond at the molecular level. And therefore, what are we? I learned today from my colleagues that we're 37% bacteria. So is that bacteria me? Is it something else? And thus immunologists use the categories that we find in Buddhist philosophy. Is this self or non-self? And so the entire question of what is self and non-self as we think about life outside our own solar system or even within it, it's a very, very powerful question and one which Buddhism has, at least I think, something to offer. Finally, cosmos. The Buddhists, I'm afraid to say, are the original flat earthers. They believe that our world is flat. They believe there's a giant mountain in the center of our world. It's flat on 4 sides. Our sky is blue because the side of the mountain facing us is made of lapis lazuli, and as the sun reflects off that, our sky looks blue. There are 4 continents and a big ocean around this big mountain. And so that one, we have a problem there. I recall during my graduate student days living in a Tibetan monastery, refugee monastery in South India, trying to convince an elderly, very learned monk that the world was round. I failed. I tried to show him photographs from outer space, so we talked about all these different things. He just refused to accept this. And when I said, with great respect, listen, we've looked all over the world. We've never found this giant mountain with one face of lapis lazuli. He said, well, if you had pure karma, you could see it. And I had no answer to that. So I think that then brings us to this question that I think all religion must face, which is that from one perspective, many, many things that religions have claimed over time are empirically falsifiable. What is left then? So why should we pay any attention to the insights of an Iron Age Indian sage who lived obviously in a pre-scientific, pre-modern community? What does he have to tell us about anything? Certainly probably very little about geography. It's also probably the case, despite what many people say, he probably has very little to tell us about quantum physics, despite the fact I've read books in which people say that the Buddha understood that in the light of his enlightenment. So we're always faced with, in the study of religion with this problem, that great religious figures are always situated in a specific time and place. The Buddha is living in ancient India in 400 BCE. And yet when he gives this famous sermon on the Four Noble Truths, he's not saying, these are the Four Noble Truths for North India at 450 BCE. When Jesus gave the Sermon on the Mount, if he gave it, it wasn't that he was saying, I'm speaking now to Jews in occupied Palestine in 32, and this is a Sermon on the Mount which is true in this year and in this time and place. These are universal truths that are set forth by these teachers. What do we do with those? So on the point of view of the big mountain, I think we have to say, listen, I'm sorry, we have to set that aside. On the other hand, in this very first sermon, the Buddha is said to have taught that humans have 8 kinds of suffering: birth, aging, sickness, death, losing friends, gaining enemies, not getting what you want, and getting what you don't want. That's pretty much my life. And therefore, we see these elements which are very historically specific and can be dismissed, and others that are also historically specific that somehow remain true. And those are the questions I think that we have to deal with as we think about these large questions about worlds beyond ours. I'll end with one final Buddhist term. I was reading the Lotus Sutra, a great text from the 2nd century CE, in which multiple universes are mentioned. And before the Buddha teaches the Lotus Sutra, he shoots a beam of light out from between his eyebrows that illuminates the entire world. And one of the things that he illuminates is a place for some beings called the Lokantarikas. Loka means world, Antara means in between. So those who live between worlds, these are people who live between heaven and earth, and they live in complete darkness. And that darkness is so profound that they are completely unaware of the existence of any other being. And when the Buddha illuminates their world with this beam of light, they say, where did these other beings come from? Thanks.
Thank you. That sets me up very well, funnily enough. In the past couple of days, also my name is Pamela Klassen, and I work on Christianity and indigenous religions in North America. So, of course, you know, Christians also were, for a while, they were pretty good flat earthers, and when Columbus made his voyage, in which he thought that he discovered India, clearly, he also thought he was going to find a mountain there that was going to do all sorts of wonderful things. But clearly, we still sometimes many people still say that Columbus discovered America, but of course, there were many people who were living here long before he arrived. So I'll talk more about that in a second. But in the past couple of days, I've learned a number of new terms that I would say have been really productive for me in thinking through this question of what do scholars of religion have to teach astrobiologists, and what do astrobiologists have to teach scholars of religion. And interestingly, a lot of our terms kind of overlap, right? So cosmology, cosmogony, even the idea of the universe or the universal is something that can be read in different kinds of ways. And one of the terms that really struck me was something that Jonathan said, called, when he was talking about cosmic horizons, which seemed like a lovely poetic term to me. We can all sort of know what a cosmic horizon might be, but apparently it's something very specific in astrobiology, which you can correct me if I didn't get this quite right, but that it's a cosmic horizon is sort of the edge of the universe as we can actually see it with the help of telescopes and other kinds of devices. And it's got a complicated relationship to space and time and other kinds of things. But basically, the cosmic horizon, like the horizons we can see here on Earth, is shaped by when we see it, literally what time in a grand sort of scope of time, historical time, when we see it, and from where we see it, right? So this phrase, cosmic horizons, is really helpful for thinking through the significance of astrobiology from the perspective of humanities, more broadly, I'd say. And I want to say, I'm not saying this is sort of like a wantonly relativistic kind of, you know, we only see what we want to see from where we see it, that sort of thing. That's not quite it seems to me. it seems like, for me, Cosmic Horizons points out how we always have to be aware of how our place and time shape what we see. And in some ways, this is what you were pointing to with the Buddha, how, you know, he's saying these things at a particular period of time, but then some of those things turn out to be, maybe not the lapis lazuli, but some of these other things turn out to be very useful and universal for us today. So this is an interesting thing to tease apart. So my work focuses, has focused in the last few years and still now, focuses on Christian missionaries who follow paths of colonialism, whether to India, Africa, China. Colonialism is a little more complicated there. As medical doctors, as nurses, even sometimes as city planners, who want to bring Christianity to everybody in the world because they understand their religion as a universal religion, right? So here we have to think about what does the universe mean in this context. They see their task is to bring a relationship with I'm working mostly with Protestants, a relationship with Jesus Christ to everybody in the world, regardless of whether those people want it or not. So these missionaries were encountering new cosmic horizons everywhere they went, almost every step along the way, in two different senses. So literally cosmic in a kind of more scientific sense of the relating to the universe as a whole. So encountering new land masses, maybe not lapis lazuli, but new formations, literally new natural environments. And then also in the cosmic in the sense of cosmologies or ways that people order the universe. So they're encountering new peoples who think about the world in very, very different kinds of ways. Interestingly, right here in the Library of Congress, you can see this in different kinds of ways. The exhibit out there of the first map of North America, or yeah, it is North America. It's a fabulous exhibit. And then what's the exhibit called? Is it up one floor or down one floor from the early Americas? The Kislak. It's a fabulous. I highly recommend coming back to see that. You can see both senses of the cosmic in effect there. So missionaries encounter these new land masses, these new environments, these new at the same time that they're encountering these new peoples. And these peoples have their own sort of cosmologies, ways of understanding their rootedness in the world. So in the context of the Northwest Coast, where I'm working with, where missionaries are encountering Niska, Haida, Tsimshian, around BC up to Alaska, that area, they're finding people who have their own cosmologies, who understand land, people, animals, and creation in ways very different from the Christian missionaries. So the Christian missionaries in the late 19th century think that they're bringing what they call a universal religion to these people who have a religion that doesn't understand itself as universal. It's a religion that understands itself as rooted in a very particular part of the world, and that the land is actually utterly central to what their religious or cosmological or community lives should be. So I think this is one thing we want to think about in the context of astrobiology. How we understand our rootedness to this world, our cosmic horizon, the place from which we have our cosmic horizon, actually shapes the values that we have in terms of space exploration or what we want to learn about the world or life elsewhere, which some people have already sort of talked about. So for the Christian missionaries, their universal religion calls them to convert everybody else, to make them like themselves. For the Niska, they're actually often very hospitable to the missionaries, but they have no desire to make the missionaries like them. So in the late 19th century, missionaries hadn't quite thought, their notion of the universe was limited to, it wasn't a flat Earth, but it was a round Earth. It was the four corners of the Earth, but it wasn't quite colonizing outer space at that point. So I think we need to think about the ways that our very understandings of exploration or discovery are rooted in particular, the ways we understand our relationship to the Earth itself and to particular places on that Earth. So when we think about astrobiology or the search for life elsewhere, when we think about what that means for our lives and for our communities here on Earth today, I think we might want to consider this earlier history of colonialism and Christian missions as a kind of cautionary tale. We probably don't want to take on a kind of exploration of space with this model of kind of religious encounter undergirding it. So our cosmic horizons, again, I think this is a really helpful term. Our cosmic horizons root us in a place and a time, but they also allow us to see other worlds that are really incredible and really remarkable. So many missionaries actually were transformed by their experience of traveling the world and meeting new kinds of people who thought about the world in very different ways. There is something awe-inspiring about exploration and about being confronted with difference, and I think that's something that is worth pursuing and is actually necessary for us to pursue in both sort of a large scale and in our daily lives. So, but that then of course raises the question that if in exploring our universe we're going to find new and different forms of life, what is our responsibility in the face of that difference? And I do not have the answer to this question. Does universal exploration come with a sense that we're setting out on a quest for conversion or a quest for understanding, or do we think that it has nothing to do with any of those values? And I would say that it probably does have a bit to do with both, and we need to think that through a bit. So I really do find astronomy very exhilarating, very humbling, and I'm excited to be able to learn from it and thinking about my own work and my own cosmic horizons. And I would say that the frame of cosmic horizons is something that's really helpful for all of us to use, whether we're scientists, scholars of religion, earthlings, whatever. And it helps us think critically about our own conceptions of the universe and the limits to our own conceptions. So I think humility is a good way, good place to start from.
Thank you. I'm Susannah Heschel. I'm professor of Jewish studies, and I am interested very much in the kinds of similarities between religion and astrobiology, and also the challenges of astrobiology for religion and specifically for Judaism. The most exciting aspect of astrobiology is the hope for the discovery of some kind of life, and perhaps even intelligible life. But the exploration itself also has a value, as Pamela was just describing. But I wonder, when we are looking to find life in outer space, I wonder why. What are we looking for? Are we looking for companions? Are we looking for recognition? Are we looking for some kind of validation of ourselves? Or perhaps some advice? How to become a better society? How to get rid of the violence that dominates so much of our world? So what are we looking for? But in the process, we're exploring. And that kind of exploration strikes me in some ways, well, it echoes some religious elements here. It reminds me a bit of the exploration we do regarding the afterlife, the search for souls, either for dead souls or for living souls, or perhaps for some awareness of God. We're searching for life, we're searching for souls, as humans have for such a long time. What's so striking from the beginning, though, is what astronomy teaches us about the vastness of space. But it's not only the vastness of space, it's also the vastness of time. And time is such an important category, certainly in Judaism, but I think in all religions. It strikes me as very important for us to keep an understanding and awareness of that vastness of space and time when we read the Bible, when we read the liturgy, especially when we read Psalms of creation, for example. I think of Psalms 104, 148, that praise the creation of this earth. To realize that vastness, to keep that in mind, also makes us perhaps reconsider certain Jewish ideas. For example, chosenness. Are we really right to speak of Jews as a chosen people, or let's say a church as the only place for salvation, only within this church, when we consider how vast the universe is, all the different possibilities of life? I wonder if chosenness or exclusivity really are still meaningful given the discoveries we've made. I also wonder, given this vastness that we haven't yet fully explored, but hope to, I wonder if we're going to be challenged with the question of whether we can recognize religious expression in life forms that may be quite different from ours, intelligible life forms. What does it mean to speak of religious expression? How should we alter how we think about that? In specific terms, Jewish theology, of course, talks about creation. How did God create the universe? One of the things that I find striking, and this echoes what Donald Lopez said a few moments ago when he spoke about the illumination that came from the forehead of the Buddha. One question the Jewish thinkers have asked is, when God came to create the world, where did God put it? If everything was nothing before God created, creation from nothing is such a central doctrine, what happened? So the answer comes from a 16th century thinker, Isaac Luria, who said that God had to contract. There was a tzimtzum, a contraction of God, in order to make space to put the earth that was then created. But how was that earth created? It came again through light forms that shot forth from God and were contained in vessels, glass vessels. But it turns out that these vessels couldn't contain the divine light, and they shattered. This is Luria's understanding. They shattered, and so divine light, sparks of divinity, are scattered around the world and have to be restored in order for the world to be redeemed. Trapping those bits of light actually is how evil comes into the world. God needs to be restored. God also needs to be redeemed. And there was a terrible cosmic accident that occurred right at the beginning of the moment of creation. So the vastness of creation and the purpose of creation has a different valence in Lurianic thinking that I think also echoes or gives us a chance to consider this vastness of space and time and what it is we're looking for when we explore outer space. But Judaism is less concerned with creation because that's God's business, God created, than it is with redemption, which is our responsibility. What is it to redeem the world? What is it to restore those divine sparks? Well, it's to overcome evil. It's to establish justice, because the main principle, the main manifestation of God, according to Judaism, is justice. That's how redemption comes about. So what will it mean then to exert justice in this realm of outer space when we do find life? Can we speak of justice when we speak of, for example, other life forms that may just be microbes, for example? What's the meaning of justice in that context? And then finally, what about holiness? Holiness in Judaism isn't something that's given to us, it's something we create. You know what it says in the Ten Commandments. Remember the seventh day and make it holy. We make it holy. So as religious people, if we want to create holiness, how do we create holiness in an outer space with which we have no contact? Can we perceive holiness or create holiness out there in the universe? What does that mean? And then I just want to end with one short teaching from a Hasidic Rebbe, Avraham Yeshua Heschel of Apt, known as the Ohev Yisrael. He lived in Ukraine and died in 1825, and he makes a wonderful comment that I think is helpful to us, perhaps, in decentering our, our lack of humility at times. He makes the comment that we human beings anthropomorphize. We speak of God in human terms. We speak of the arm of God, the finger of God. All right, that's what we do. We image God in human terms. But then he says, how do we look from God's point of view? What would it mean for God to think about human beings in divine terms? Now, of course, it's an idea we can't explore. We can't even begin to describe what that would mean because we would immediately begin anthropomorphizing. But the ability to decenter ourselves and to remember that it's not only we who imagine God and the universe and other life, but to imagine that we also are viewed and imaged by God in very different terms that we'll never know, in fact, never know and never be able to express. That I find very helpful in considering the vastness of this kind of exploration astrobiology is examining. Thank you.
Greetings. I'm John Hart, professor of Christian ethics and socio-ecological ethics at Boston University School of Theology. And my approach has a background of immersion in Christianity, but also in Indian, as an American Indian, spirituality and attitudes toward the earth. So I begin with a saying in Lakota, "How mitako yasin," greetings all my relations. The first time I heard this, I was at International Indian Treaty Council in Montana, and an elder got up, and each of the sessions of the Treaty Council meetings began with an elder's prayer. And the very first one, the elders said this, "Greetings all my relations," and he translated into English. And I'm looking around, there are people of variety of colors, ethnicities, backgrounds, and so forth. And I said, well, it's really recognizing that we are all related. We're all the same in some ways. We share common humanity. A couple of days later, a different elder began in the same way, but he gave a fuller translation. He said, "Greetings all my relations, greetings to all the two-legged people, greetings to all the four-legged people, greetings to all the finned people, greetings to all the winged people, and greetings to all the rooted people. That my relations are not just other human beings, but rather all life is intimately related to me, and I should recognize that and respect all life as the winged people, the four-legged people, and so forth, not just the two-legged people." So the sense of all of us are interrelated. And when we think about the impacts of finding extraterrestrial life, just focusing for now on microbial life, what sorts of impacts might it make on our consciousness? The historians often talk about two types of displacements. The first displacement, the Copernican revolution, when people first heard that the whole universe does not revolve around Earth, but rather the Earth is one planet circling the sun. That was really mind-shaking for those who heard it initially. The second displacement was Darwinian evolution. So people thought, well, if Earth is not the center, at least humanity is unique. And now to find out that we've evolved from previously existing creatures, kind of a second kind of displacement. The third might very well be discovery of life elsewhere in the universe, beginning in our own galaxy and perhaps as near as Mars. Well, how will that affect us? So I think that one way to look at this is to try to think about our interconnectedness and our interrelations. I'm cutting some points out here. In the 4th to 5th century, some of you might know the name Maximus the Confessor. St. Maximus is one of the few saints acknowledged by both Eastern and Western Christianity. He's a saint in the Orthodox tradition, and he's a saint in the Western Christian tradition. And he has this beautiful expression about the creation and the relation of creator to creation. He talks about the Logos. If you're familiar with the Gospel of John, in the beginning was the Word, and the Word was with God, and so forth. So Logos is the creating Word. Maximus says there's a Logos and Logoi in the plural. Every existence, not just humans, are Logoi. That is, they have a presence of the divine in them, whether they're trees or humans or elephants or eagles, whatever else. Everything, not just living beings, all have a spark of the divine in them and are always, in a sense, in a dialogue with their creator. So that would extend throughout the universe, of course. If all creation, it means if other life exists in the universe, that this also, this also is Logoi. We live in a sacred commons, I would suggest. It's sacred because it's birthed by the Spirit. It emerges from a divine being. I think of creatio ex Dei, not creatio ex nihilo or creatio ex materia, but rather it's a cosmic birth of some sort. It emanates in some ways. This is not traditional Christian theology. Emanates in some way from the Creator. There's not nothing and then something or some kind of a pre-existent matter. So I see it as actually flowing from the Spirit, which links to Maximus, the Logos, and the Logoi, that there's always this connection. It's sacred because of its origins, but also because the immanent, transcendent Spirit is present here. St. Paul in the Christian tradition talks about, in God we live and move and have our being. So God is intimately present, permeates creation. Francis of Assisi is known as someone who had a very close relationship with all creatures. You might be familiar with his famous different titles for a Canticle of All Creatures, or a Song of All Creatures, also called the Canticle of His Son from its first verses. If you read it carefully, Francis calls everything there brother and sister. Our Lord, brother, sun, our sister, mother, earth, our brother, fire, sister, water, and so forth. If you're familiar with Francis and pictures of Francis, who has this relationship to animals, there's no animal mention in that. And you wonder, wait a second, here's the saint who always spoke with, preached to birds, and so forth. And the reason is that when he wrote his song, it actually was a song that he sang when he approached villages. The original melody was from an Italian romantic ballad of a time, which celebrated the beauty of the flowers, the beauty of the deer, and all these kinds of life. So when the people in the village would hear Francis approach, they'd hear his words, which were new, which are talking about what we would call inanimate creation, being brother and sister, but they would already know about all the animals being close to us. It really is a song of all creation, if you couple that, the original expression in words, and then what Francis did with that melody. If you're familiar, the biologist emeritus from Harvard, Edward O. Wilson, talks about, in his book, The Creation and Appeal to Save Life on Earth, about how we should relate to each other. It's a generic letter to a Southern Baptist pastor, the tradition in which he grew up in the South. And he rejected after he was told you can either believe in Charles Darwin or Jesus Christ, and he had done a lot of study about evolution, so Darwin was very real to him, and Jesus not so real, so he went off on a scientific career. And didn't want to have a part of, in a sense, of Christianity, except to this book. It's a generic Southern Baptist pastor, and he says, let's meet on the near side of metaphysics. So let's put aside our ideologies on metaphysics. Let's meet on the near side of metaphysics. He said, religion and science are the best hope that Earth has to save its life. So religion and science should work together. And that's a bit of a change for him from his past writing. So he's urging this kind of coming together. Because we have to put aside whatever religious, philosophical beliefs we have and see what is the real way that we should become engaged in trying to save the Earth. Disclosure, as they say in TV, I wrote a blurb for the book, and he wrote a blurb for my book, Sacramental Commons, which came out within a month of each other back in 2006. An experience I had many years ago, I was on the South Padre Island in Texas. I was part of a three-member ecumenical team that kind of provided counseling and cold water for surfers. South Padre Island is very famous as surfing territory. And one evening, as the surfers coming in, a very pleasant sound, the sunset was beautiful, purple clouds, red clouds, orange clouds, and these three surfers, who were obviously friends, were trying to convince each other. Each of them believed they belonged to the only true Christian religion. And I want my friends to be saved just as I'm going to be saved because I belong to this religion. So imagine three friends, each of whom is absolutely convinced that they have a true religion and they really want their friends to be saved. So they're quoting scripture back and forth, the kind of usual thing of the battle of the verses. And finally, one of them says, why don't we pray in tongues? And I'd never heard praying in tongues or glossolalia. So the three of them sat down on the beach, and these male voices, just this tongues that I'd never heard before or since, just floating in the air with the sunset, the waves lapping in. It was so beautiful. And I couldn't help but wonder, as the three of them got up and went their separate ways, there's two possible ways I thought that they could be thinking about the experience. Gee, it's too bad Dick and Harry are going to hell because, I mean, they sing and they pray in tongues, but they don't have the true church. Or, gee, if Dick and Harry can also pray in tongues, maybe there are at least three churches you can belong to in order to be saved, and maybe more beyond that. So it kind of opens things up, an incident like that. Finally, I'll close with a quote from Gabriel Funes, a Jesuit priest who is the director of the Vatican Observatory. He was asked about 5 years ago by a reporter from Osservatorio Romano, is there intelligent life elsewhere in space? And he says, very highly, it's likely. He said, in fact, it might even be more intelligent than we are. And the reporter of Osservatorio Romano was shocked because you have a Jesuit scientist, head of the Vatican Observatory, who's saying, yes, there can be intelligent life elsewhere. And so he said in kind of amazement, well, so how do we relate to them? Remember St. Francis' Canticle. He said, St. Francis said we should regard all that exists, all creatures, as our brothers and sisters, and we should do no less for any other life that we encounter. Thank you.
Thank you all. And now we're going to open it up for Q&A. There are microphones here, so if you could step up and form queues, and I'll call on people in succession and try and keep that as much in line with when people get there as I can. Hi. Why don't you just get...
Thank you for a very stimulating discussion. I wanted to pick up upon what Professor Hart was saying when he talks about displacements, the Copernican revolution and Darwinian evolution. A philosopher has said that intellectually, we have proceeded from the closed world to the open universe. And for some people, this expanding of our borders of awareness has been threatening. I can only allude to the fate of Galileo's trial epitomizes that. Why was it so threatening to church authorities and so forth? Again, this whole geocentric, anthropocentric universe from Aristotle on through the Middle Ages has wreaked havoc amongst the dogmatic theologians' minds. But there's, when Giordano Bruno was burned at the stake for talking about the plurality of worlds, and maybe there be other beings in other worlds. Of course, I was reprimanded by a theologian who said, that's not why he was burned at the stake. But I've certainly played a little part of it, at least. So, but on the other hand, there have been other, I'm finishing. There have been other philosophers and theologians in the Christian tradition, like Cusanus and Teilhard de Chardin, who speak of an infinity of worlds as betokening the glory of God. And this is a testimony to the infinite power and beauty and grandeur of God. So I would think that within, just finishing, within the Judeo-Christian tradition, I would think there would be much more difficulty of reconciling intelligent life on other planets than with, say, the Buddhist tradition. What would we do about a cosmic Christ, for example, or cosmic Moses? Do they go, or have they visited other planets, other worlds?
There is obviously a lot in that question, and our focus here was on microbial life. I just mentioned that because that represents kind of openness to all kinds of life, and St. Francis' approach to all life, or even microbial life that we might discover, or Maximus, it all has the logo. They're all logoi with the presence of the logos in it. The plurality of worlds question actually goes back to the Greek philosophers. Epicurus, who was an atomist, thought there was an infinite number of worlds and so forth, and you get carried through. And in Christian thought, Aquinas rejected it. Giordano Bruno was burned at the stake in 1600 for, among other things, expressing plurality of worlds. It was threatening to Christian theology, because if there are many worlds, then did Jesus or did God become present or incarnate on all these other worlds and have to keep jumping from world to world as different maturity levels came along and so forth? So they really wanted to reinforce the doctrine of the incarnation. It went through several, it becomes an acceptance of that in the church. Aquinas was condemned for saying God couldn't create a plurality of worlds, and then the next teaching in Catholicism was that you're denying the omnipotence of God then, so yes, God could create a plurality of worlds, but God chose not to. So there is no plurality of worlds, therefore there's no incarnation concerns and so on.
Let's go here and then go ahead.
Thank you. Thank you very much for a very interesting discussion. It was really wonderful to hear your ideas about this truly interdisciplinary topic. And I was wondering, for the past 2 days, when you had a discussion, you had discussion about the definition of life itself. Because I asked this question because, when Dr. Benner mentioned, we might be, as a human being, we might be restricted in our imagination, because the life form we see in the earth, it has fundamental similarity in structures. So I wonder, in different disciplines and different religions, have any different definition of life or the way you see the life, and that discussion could lead to more, I don't know, more interdisciplinary, more open ideas about what might constitute life itself.
Well, yes, I mean, the definition of life, like most definitions, can tell you more about the definer than it can tell you about the defined. And certainly when in 1994, NASA convened a panel that was chaired by Jerry Joyce, who came up with the concept of life as a self-sustaining chemical system capable of Darwinian evolution, and that definition was very much influenced by Carl Sagan, who had that very much as his focus. Now, how many assumptions are written into that definition, right? Well, chemistry I'm all in favor of, right? but it is requiring a, so if you are a fan of Star Trek, when you have Q, the space alien who flits in and out of the continuum and giving Jean-Luc Picard a hard time, right, that is not necessarily a chemical statement. There is, of course, a lot of science fiction which actually describes alternatives. Self-sustaining, by the way, does not mean that you don't need to eat. That means that you, however, are able to go out on your own and get the food that you need without having to have someone else feed you. But the most challenging problem is Darwinian evolution. We certainly believe that in the natural history of the past, this ability to have children, where the children are not quite exact replicates of you, but where the imperfections in that replication are themselves inheritable, is how life got started. But Darwinian evolution carries a lot more baggage, one of which is that those mutations cannot be prospective, that is, they cannot anticipate future needs. But of course, everybody in this room right now is the product of prospective cultural adaptation. The clothes that we wear, we are perceiving needs, adapting them to us, and then making that information available to our children. And in fact, that's one of the reasons why you and your kind are such a threat to the ecosystem out there, because you are producing a kind of evolution that has never before been seen in this biosphere, as far as we know. But it's only going to be a couple of years, perhaps, before genetic engineering allows you to change your genetic matter in a way that is prospective, right? You certainly don't want to give birth to a child who will have hemophilia or any of a number of other genetic diseases, and there will be the technology to prevent that from happening, which will release you from the one constraint that Darwinian evolution has that is so onerous, that is that to maintain your genetic information and to get better information, children must die. And that's, of course, something very unhappy from the point of view of Darwinian evolution, or your children must get eaten or something equivalent. So yes, I mean, what we can say, and this is where we're back to what Susannah is saying, we might very well would like some advice, because if an alien species that is more advanced than us finds us, they will most likely have gained control of their biology sufficient that they can evolve without having children die. And so we would probably ask them how to do it.
Just add one point to this. In Judaism, and based on the Bible, all that stands in relation to, let's say, to human life is considered part of life. That is, the earth is also part of life. The earth receives a sabbatical in the 7th year. You don't plant, allow it to rest. All that goes into it, the minerals, and everybody knows this. If you are low on potassium, you eat a banana. Where does the potassium come from into the banana? It comes from the rocks. So the rocks are also part of life in that sense. It's a much broader inclusivity that is based on relationship. One helps the other.
I would add to it that NASA is very aware of that problem. Will we recognize life, even if it has the same constituent parts or elements that we do? Will we recognize it because it might be different? It might have different aspects to it. They talk about looking for biosignatures. First of all, how do you decide what the biosignatures are? That is evidence of particular kinds of life. And what if we miss some? We'll miss different kinds of life. So they're very aware that it can be a problem. We don't know every possible type of life. We're discovering new kinds of life on Earth, near the vents, in the oceans or out in the Arctic that can withstand extreme cold. We haven't even traced all the species here, let alone on a completely different environment. And of course, species are interrelated with their Earth environment and whatever kinds of changes are taking place there. So NASA recognizes this problem that we can't predefine as much as possible. We'd like to, so at least we know elements of life as we understand life if we find traces of that. But there might be other kinds that we just never conceived of because we have no experience of it here on Earth.
Hi, I'm Steve Garber. Thank you, Dr. Hart, for bringing up 2 points that I think are important and that I've been thinking about a bit lately, the Darwinian revolution and the Copernican revolution as sort of touchstones for paradigmatic shifts in people's thinking about our universe, our world. So I wanted to ask you and Dr. Heschel to expound on that a little bit more and see what you think we can learn from those historical analogs about what will happen when I predict that we will find extraterrestrial life at some point in the future. Will those be useful models for thinking about it? And also, in particular, sometimes I wonder also about the difference between those 2 historical models in that it seemed to take a while for there to be scientific consensus around the Copernican revolution, but it seems to be taking even longer for there to be general social consensus around the Darwinian revolution. We as a society are still arguing in general about intelligent design versus Darwinian evolution and natural selection. And if you agree with that, why is that?
There's a lot, of course, in that question too. Talking about the displacements, I think one thing it teaches is that we cannot universalize the current state of knowledge of science or of religion. We have to be open to learning new things, learning in religion things from other religious traditions, learning from science, maybe new facts that come along that we wouldn't have thought about before. Copernicus and Galileo are very threatening. Most people in the world would never have heard of them. Everything still looks the same. The sun goes around the earth, and the moon goes around the earth. We're the center of the universe and so on. So it was really in Western civilizations and those influenced by them. But again, you can't freeze a particular moment. When Darwin came along, as you mentioned, it became harder still because, well, if we're not the center of the universe, at least we're the center of something. We're the top dog on earth, so to speak, and everything revolves around us in other ways, not in terms of circling us. But at the First Vatican Council, the Catholic Church actually considered condemning Charles Darwin because it saw the threat of the idea of human evolution having for doctrines of creation and incarnation within the Christian tradition. And the wiser minds and voices prevailed. Some of the cardinals at Vatican I suggested, we don't want to make the same mistake with Darwin that we made with Galileo. End of discussion. So they put the book Origin of Species on the index of forbidden books, but they didn't condemn Galileo and saying evolution was wrong. And luckily for them, of course, they didn't make a second major mistake. By the way, they retried Galileo under Pope John Paul II. It cost $1 million. They had a trial in Rome. They had people sit in the places of all the people involved in the trial, and they acquitted Galileo. So it's as if the first trial never happened because now we've displaced it by this later trial centuries later. Somehow that made the first one not occur. That's a different kind of theology in mind. But in any case, we have to be careful we don't make those mistakes in the first place, but not kind of leaping out to some, whatever the issue might be in science or religion or encountering life in space, but be open to what that might mean. Start thinking creatively about how we might be able to understand that and relate to it instead of condemning it, first of all, because it's threatening in some way to our psyche or to our civilization or religion or whatever.
I would just add that Copernicus, Galileo, Darwin never posed theological challenges to Jewish thinkers. There was never a crisis because of scientific discovery, and there's always been a sense that Judaism and science go hand in hand. It's not a problem, and that's great. I do think, though, that one point that we're learning from this is a reminder, let's say, to Jews. In Judaism, we do not worship the soil. Space can be, let's say, time can be sanctified. Space is not sanctified. And perhaps that's a lesson that we need for today.
So you said that, there were 3 tests that were detecting life on Mars, and they all came back positive. Does that mean that there is life on Mars?
Well, yes. That's a subject of major discussion right now. So what they did on Mars was they put food on the surface of Mars. They happened to make the food radioactive so that they could detect carbon dioxide that was released when they sprinkled the food on Mars. And that's because if I feed carbon-labeled radioactive food to you, you exhale radioactive carbon dioxide. And they detected radioactive carbon dioxide coming off the surface. The second thing that they looked for was the evolution of oxygen, because if you go out to your backyard and put water on the soil, right, and the plants with photosynthesis will evolve oxygen, and they put water on the surface of Mars, and oxygen was evolved. The third thing they did was they looked at what they call carbon fixation. That is, they put carbon dioxide with radioactivity, again, to keep track of it better on the atmosphere above a little square plot of Mars, and then they put it under the Martian sunlight, and they waited for the soil to fix that carbon, and it did, and they found a small amount of carbon dioxide. And now Gil Levin, who is the man who designed the first of those experiments, he's still alive, and he will tell you that he is the man who discovered life on Mars and has raised, even relatively recently, the question is, since those tests were positive, why have we not gone back to the same spot to confirm them? because that's what we teach in school. Perhaps you've learned it yourself. Reproducibility is what scientists should do. We have not. It's an amusing cultural statement that at the same time as the cameras were rolling where these Viking scientists were getting the positive results, another result was coming along from a man named Klaus Biemann, who had built a mass spectrometer to go to Mars looking for reduced organic molecules, because as John has told you a moment ago, reduced carbon is believed to be a sign of life as well, and that mass spec failed to find it. And so what you discover is the first 3 experiments are what we would call the metabolism theory of life, and it's also a very earthocentric metabolism. I've made reference to metabolism that you have and your plants in your garden have. You know, that's really not very broad, right, in terms of our conception. But then the second thing, when they couldn't find reduced organic material on the surface of Mars, what we learned is that in their minds, the reduced carbon theory of life trumped the metabolism theory of life. So when they found no reduced carbon, they said, oh my goodness, all those metabolism theories were not as strong. And by the way, just to show you how science works in the real world, no sooner did they fail to find organic material on the surface of Mars that they came up with explanations for why those other 3 tests could have arisen without biology. And that's, of course, now we now know that the interpretation of the mass spec is incorrect. It turns out that they did not do the correct job. In fact, this is, if I've made a small contribution to the search of life, this is actually one of my papers, but let's not go there. So the question now is that once the Trump argument that caused the first set of arguments to be discarded turns out to be incorrectly interpreted, we have to go back and rethink the entire thing. And so yes, the reason why we don't believe there is in Mars, remember in science there is no proof, there really is no disproof, there is sort of burden of proof. And it shifts back and forth as various science argue out with each other, very much often personal, and we hate each other and all the rest of it, right? But the burden of proof right now is to establish the affirmative that there is life on Mars. It is not in the hands of the people who have to disprove life on Mars. And that was very much different in 1976.
Okay. Last question right here.
Thank you for such a fascinating conversation. One thing that's come up multiple times is how these different philosophies and sciences and religions perceive these concepts and really define them. And I'm wondering, has there been any conversation about how to translate the idea of life from this very chemical and biochemical concept to these other concepts that really, you know, more people than just, you know, these eminent scientists can really understand and believe in?
That's a great question, and certainly we had lots of debates about that in our last 2 days, and I mean it ties to your question as well. I do think there is something really productive in forcing us to think about microbial movement as life in some sort of way. On the other hand, I think we need to think, I always think we need to think historically as well, about how sometimes when we find life, we haven't treated it very well, right? So we need to really, what does it mean to dig, if we were able to dig up the crust of Mars and there was life there, would you be killing some life and digging up the crust of Mars, and would it matter? So the whole idea of what we as in different contexts understand life to carry as a concept is very, very fraught, and very fraught in different religious traditions as well. So when, for example, when missionaries found other beings in the Americas, at first they had to have a long debate about whether they actually had souls or not, right? And souls were the ways you would define whether someone was a beast or whether someone was a person, right? So there's lots to learn from history in this question, in that question, but then I think there's also lots to learn from thinking scientifically about how our definitions of life are always sort of in some ways provisional, right? Do you have something you want to add, Donald?
I like that.
Okay.
But that was pretty quick, and I think we do have time for one last question, then one more.
Yeah. My name is Farhana, and thanks for the enlightened dialogue with the great mix of perspectives. I'm going to pose a very short question, won't be taking much of your time. What could make one free from the fear of death or pain? The skeptical wisdom or blind faith?
Or both.
Or none?
That's yours.
Done. Yeah.
So I think the fear, one of the issues we've been talking about over the last couple of days is that not only can we not define life, we can't define religion. And all of us religious scholars have renounced that quest of defining religion. However, in some of our conversations, we talked about it having to do with something to do with the fear of death and what happens after death. And I think each of the traditions has its own answer to that question, and whether we want to accept that or not, I think is something that science has challenged in many ways. It really is a question about what exists after that moment. Does something continue? And how would we prove its existence? That remains the perennial question of all religions, and I think of science in a certain sense, and I think that's the one that we all continue to struggle with. So maybe rather than trying to give the Buddhist answer to that, I would just leave that question open because it's the most profound question of all.
I'm going to take moderator's prerogative to add one thought there to end on. The juxtaposition of blind faith and skeptical wisdom is so polar, but of course most people live somewhere in between the two. And many people oscillate back and forth, and I'll tell an anecdote from a colleague of mine who's a scholar of Hebrew Bible and teaches about early Christianity, and had a student ask him once, well, are you a Christian? And for whatever reason, he was in the mood to give a particularly candid answer, and he said, some days. You know, I think a lot of us feel that way about whatever worldview we hold, you know, that if you're a human being and you're fallible, you have to have a little bit of humility about it, and that's part of the skeptical wisdom. But the faith doesn't have to be blind. We're all searching for answers, and as you saw here, all of these people, not as religious practitioners, but speaking about religion in a way that is knowledgeable about its practitioners. I don't think anything they said had anything to do with blind faith. It was about searching faith, and searching is what all of this is about, right? That's the theme for the day. So thank you all very much. We've got refreshments. Please hang around and have some casual conversation.
This has been a presentation of the Library of Congress. Visit us at loc.gov.